Hello, everybody. I hope everybody is doing well today. Um, I hope you guys, give me a little forgiveness here. This is the first time I have taught this class online, and so I'm a little disorganized a little bit from, being in class for 12 years, doing this in the classroom and have the chance for this online. But I'm trying my best, and I hope you work with me. I'm going to try to do what I can to make this an enjoyable class for you. I really want you to enjoy it. So last class we are talking about last lecture we are talking about how we determine environmental science. Environmental science is the study of the environment and humanity's role in it. Okay, our interaction, how we harm it or how we use it, or all that other stuff that goes along with that. Okay, and we use science to guide our decisions. So we use science and the scientific method to decide what is going on out there through repeated observations and repeated experiments that give us the same results time and time and time again. And these experiments, to be a scientific experiment, that means you too can do it. All right. You too can realize that carbon dioxide is a greenhouse gas by making your own little greenhouse and pumping in some carbon dioxide in there and seeing that it gets warmer. All right. If you don't believe me, you can just go to Mythbusters and Google Mythbusters kids do greenhouse gas experiment, and they show you how to set one up. All right. And they got the same results. Okay. We also talked a little bit about ethics. Now, science tells us what is and what is not. Ethics is our judgment on how to apply those. Okay? So, we talk about the golden rule, treat everybody as well as you want to treat you. But sometimes, business needs to make some money, so we need to find a happy medium sometimes. Um, in society here in the United States, we have what's called generally considered safe. We can't get rid of all the lead out in the world, but we know that if we, live with just about this much lead in our bodies, we shall be okay. We're not going to die. So we allow some of that lead to actually get emitted into the atmosphere when we're burning coal, because we can't stop everything. Okay, and we'll learn that in the next chapter when we talk about the laws of thermodynamics. Okay, so our ethics can vary from culture to culture. Okay, there's not one right way to live. But in my humble opinion, there is the universal golden rule of treat everybody nice. Okay, and we also talked about the ecological footprint and what that is, and that's just an individual's consumption of raw materials, natural resources that it takes them to live in a day or a year or their lifetime. Okay, and this is a equation that was come up about back. Well, we've kind of always known about the ecological footprint, but we finally got the supercomputer model going on this in the 1968. I think they put it out in the Limits of Growth book. It was the first calculation, and what that calculation was showing that we were an overshoot. Okay, and if you go back to that PowerPoint, there's a video in it. I want to show you the video of Mathis talking about the ecological footprint. This is kind of old, and it's not as newfangled as all the other ones. You can see there's only been about 137 views of this, and this is probably all my views for my 12 years of being in class. All right, so let's watch this video, and hopefully this will give you a better understanding of what the ecological footprint is and how we actually equate it.
The ecological footprint is a resource accounting tool. So like we have accounting tools for money, that we want to know how much money do we earn and how much money do we spend in order to know to what extent our assets are going up or down, we have the same need with our resources. Like any nation, I think it's more important to know for nations how much ecological capacity they have available and how much they use rather than knowing how much gold they have in the national banks. Because in the end, what we really depend on is natural capital, the ecologically productive force of nature. And so the ecological footprint is a resource accounting tool very much for this natural capital. So it does this both on the income side or on the supply side to find out how much ecologically productive capacity is available. And we do that in number of hectares or acres for Americans are available in a region or on the planet that provide these kind of services. So these areas are forest areas, pasture areas, crop areas, fisheries, but also the urban areas, which partially are built over, but mostly stand on the most productive land that we have on this planet. So that's what we have available. Then we can compare what we have available against what we use. Like if we have a farm, it's obvious that we could consume milk. That takes a cow to graze. So this area necessary to provide for the cow that then provides the milk that I will eventually consume. Uh, so in the same way, for all resources, we can find out how much area is necessary to provide the resources that I consume for fibers, food, energy, waste absorption, etc. That adds up to like a spread farm around the world. Like by, I don't know, by 9 o'clock in the morning probably I've already visited about 3 continents. Like for the, let's say I may wear some wool from New Zealand sheep, I may drink some coffee from Colombia, I may eat some wheat from, I don't know, the Midwest, the United States. So all these pieces are used by me to provide the resources that I consume. So we can do a resource balance for myself, so we can find out how much ecological capacity I use. We can do it for a whole nation. When we do it for the world as a whole, what we see is on average, we have about 1.8 hectares of ecologically productive space available on this planet. Or in American measures, that would be about 4.4 acres of ecologically productive space. That includes also productive sea space. And then we can compare that with how much we use. Our global accounts, or global average, shows that we use about 5.5 acres or 2.2 hectares of ecologically productive space, or about 25% more than what is available. Now you could ask, how is it possible to use more space than what we have available? And essentially it's the same as how can we spend more money than what we earn. Of course that's possible for some time because we deplete our assets. In the same way, we can cut, for example, trees more rapidly than they regrow. So if we assume we had 1 acre of forest and we use the forest, or we harvest timber from that forest at twice the rate of what the forest regenerates, that's like using double the area at the regenerative rate. So the footprint of the products would be 2 acres, while the biocapacity would be 1 acre. So in this case, we would use twice the capacity of what we have available. If we look at all the resource flows combined together that humanity demands today, actually the last numbers for 2003, we believe that, or our conclusion comes to that we use about 30% more, or 25% more than what nature has available. And what's the effect? We call that overshoot, that we use resources more rapidly. It leads to an ecological debt, an accumulation of ecological debt, like, for example, accumulation of CO2 in the atmosphere, deforestation, soil loss, or overuse of freshwater resources, etc. So overall, like with money, in the long run, we cannot spend more than what we earn, otherwise we go towards bankruptcy. And that's what the ecological footprint tries to avoid, helping humanity and nation by nation to avoid ecological bankruptcy. Now, bankruptcy is a serious concern. In the financial world, I would say in the ecological world, it's even more serious, because at a financial bankruptcy, you can move out again later on and kind of rebuild your life. But with ecological bankruptcy, it's very hard to move out of, because ecological assets are the underlying wealth on which any other wealth depends.
Yeah, I really like that last statement. All of our wealth depends on our ecological biocapacity. There's a guy called Adam Smith who kind of is like the god or grandfather of economics. And he wrote this one book called Wealth of Nations. I don't know if you guys ever heard of it. But it's basically based on every nation's wealth depends on how much natural resources they have, how much land they have, how much water they have. And today, back in Adam Smith's days, they didn't have fossil fuels. Well, they might have been using coal, but they didn't know too much about oil and stuff. But it was how much they had of that, how much gold, timber, all right, and even later on they added in labor, all right. And we need to be, as a society, understanding the Earth's biocapacity, how much stuff it has for us to be able to use. And they have, of course, a website for this, and I think you guys go to this website to do one of your homework assignments, you guys do your carbon footprint and ecological footprint. You can figure out this is where it's all started, all right? And you need to decide whether or not this is first justified to even think this way. But decide whether or not your ecological footprint is good. So take some time and look this website up, the Global Footprint Network, and it talks to you all about everything. It talks about the data platform, and has a footprint calculator here for you. All the data that you need if you ever want to do a study about this or do a paper on the ecological footprint. They got all this data. And what I love about this site is, sorry you guys can see that my internet is kind of slow here. I live on a farm and I don't have high speed stuff. They have all that data is open. So you as an individual can use what I call your critical thinking skills, what everybody else calls your critical thinking skills, and see what they are saying is right. All right. And I'm just going to get out. I'll let you guys do this yourself so I don't waste time on my computer alone. But go and explore some of the data, all right? And see, here's our overshoot right here. This is where we are today in 2000. Oh, this is 2013. Holy guacamole. We're already an overshoot, okay? And then just go through all the different data and just take a look, okay? Because this is what we're going to try to learn here in this environmental science class is how all this kind of, not this equation or whether or not you should be using stuff or not using stuff. It's just about assessing Mother Nature, using science to assess Mother Nature of what she can provide for us, and then how we're actually impacting that. If there's going to be enough left or if we're just polluting ourselves to death, all right? So take a look at that website, okay? And then also we have a couple slides I want to go over for you. And like I said, I wanted you guys to use your critical thinking skills when it comes to this stuff, okay? Not just what I say, but what all your professors say out there, all right? So critical thinking is simply a process of determining the truth. Okay, so if you are saying, "Am what I'm hearing is true?" you're practicing critical thinking. All right, but critical thinking takes a little bit more of more steps. All right, it's just not sitting there saying, "Is this true or not?" and saying, "Oh, that's a bunch of hubbub." It's going to find out if whether it's not. All right, it's going to go and use that scientific method and seeing if 2 + 2 actually equals 4. All right. So when you're doing your critical thinking skills and applying them in this class and all your other classes and even in your life, and I think we do this just naturally as humans, all right? I want you to think about things. And, what is the purpose of your thinking? Why am I thinking this way? Is it being biased? Is it because I'm hurt? Is it because I'm want to get rich? What? Okay. Also, what precise questions are you trying to ask? You got to narrow down your questions to define the hypothesis. All right. From what viewpoint are you thinking? All right. Am I being biased? I have my political leaning is I'm a mad liberal. All right. And I got to remember that sometimes when I start talking to individuals because I have a certain bias. That's the viewpoint of my thinking. What information are you using? We're going to go over this a little bit later in the next slide about the baloney detector. But are my sources real? Are my sources valid sources where people can actually, or has it been sourced and proven and verified? Also ask how you're interpreting the information. All right. What are you using to decide whether or not you're using the right math? Are you using the right science to apply to whatever you're researching? What content or ideas are central to this thinking? All right, so my liberal thinking and the political views, be kind to each other, but even conservatives are supposed to be kind to each other too. All right. What conclusions am I aiming for? And this is a tough one because sometimes you don't want to actually have a conclusion. You want to come in with an open mind, but we need to have some kind of hypothesis. We need to have some kind of thing we're looking for. So if I say, am what I'm thinking is true, okay, let's find out that if that statement is true, and that's what conclusion we're trying to find. What am I taking for granted and what assumptions I am making? There's a lot of assumptions out there. You know what they say about assumptions. When you assume, you make an ass out of you and me, right? But assumptions are important. They have to be, as long as you're clarified before you put out your information. When you put out the information, you say, this is my 4 or 5 assumptions. One thing, like for example, when we do sustainable forestry models, all right, I've done it before, but I'm not like doing them all the time. But I've done them, and some of those assumptions are that all the trees. One of the first assumptions is that all the trees go back at the same growth rate. All right, when I think about that, I'm like, yeah, you gotta be crazy. Not all the trees grow back together at the same time, right? But we need that to make the model a little bit more consistent. All right. But as long as you know that assumption exists before you are, when you're equating that information, you can make up your own mind. You can decide whether or not that's true or not. Okay. If I accept the conclusion, what are the implications? What if this stuff is true? What do I need to do about it? Anything or something? And what would the consequences be if I put these thoughts into action? What would happen if I actually decided to take the next step and start cutting down some of these trees without doing a proper sustainability research in that? Would I run out of trees? Would the story of the Lorax come true again? Okay, so those are just the steps in critical thinking. I hope you all use your critical thinking skills during this class and all your classes. All right, and don't be afraid to ask questions. All right, that's what it's all about here in school and even later on in life. And then we also have, along with your critical thinking skills, I hope your critical thinking skills allow you to use what's called the baloney detector, right? And it wasn't me; it was actually Carl Sagan, a man much, much, much wiser than myself. He's may rest in peace. Came up with the baloney detector, right? And it just basically finding junk science. But you can also use this today in fake news stuff. All right, so when you're going through your current event projects and looking for something to write about, evaluate the source and see if some of that stuff might be baloney. And if that ends up being baloney, I'll tell you. But I think you're probably smart enough to figure out what's really happening out there in the world, or what's relevant or what's not relevant. So number one is how reliable are the sources of this claim? Is there a reason to believe that they might have an agenda to pursue? All right, the easiest way to do that one is just follow the money. All right, sometimes there's an organization called what are they, the Heartland organization, and they are what some would constitute global warming deniers. Right, they would I would put them in that camp. And when I follow the money, we see that they're all funded by the Koch brothers and some other big oil. So these things that they're putting out are being financed by the people that want to try to keep releasing the carbon into the atmosphere. Okay. Have these claims been verified by the sources, and what data are presented in the support of this opinion? All right. So a lot of times when you see some fake news, there's no reliable sources. So when you're looking through your current events, if they got a lot of links with inside that article directing you to other supporting evidence, you got something good there. All right. But go and check that supporting evidence. All right. So if you're going to you got to go up and check that supporting evidence as well. And if it's starting to make sense, then there's starting to be more and more people are saying yes and yes and yes, starting to look more and more true. What position does the majority of the scientific community hold in this issue? So, there's always that people in climate change always say, hey, 97% of the scientists say that it's true. That can't be right. All right. First of all, that's not 97% of the scientists. It's actually 97% of the peer review research papers. And that other 3% that's not in there has actually been looked through and found to be not reliable information. And I have a source for that if you wish. You can say, hey, Professor Buckner, you tell me what that's true. And guess what? I can provide you that link to that paper reviewing all the like 3,000 climate paid papers over 10 years, right? So the majority of the scientific community says yes. Okay. How does this claim fit with what you know about the world and how it works? Is it reasonable assertion, or does it contradict established theories? All right, so use your common sense and your critical thinking skills and say, is this something that I've been taught since the fifth grade or not? Are the arguments balanced and logical? Have proponents of the particular positions considered alternative points of view, or only selective supported evidence for their particular beliefs? Now, this one's a tough one. Sometimes they call this cherry picking data, right? Um, so there's a lot of articles out there that would just, pick one or two certain data points, and then they say that this is makes something true. Okay, you have to be wise enough and smart enough to look at these things over and say, hey, maybe this isn't all the, maybe they're missing something. Okay, and consider the alternative points of view. And yeah, I hate to do this, but I have to do this. When I read up on things, I see one of my friends is notorious for not believing in climate change. I read those articles he puts up, and then I'm able to rebut them very easily, of course, because it's not an argument based in logic or fact, right? And in the most of the world already knows, the scientific community already holds the truth of this issue. Okay, but I read those things so I can keep on top of what is actually going on out there, and I can find out what other people are saying, so I can defend my issues. Okay, so look at both sides of the argument, but remember, science is science. We either reject the null hypothesis or we accept the null hypothesis. There's no ands or. There's no two sides of global warming. The climate is warming up because we'll put more carbon dioxide in the atmosphere. That's just a law of physics. All right? We can't break that. What do you know about the source of funding for the particular position or studies financed by groups and other partisan goals? So know who is funding these organizations. Okay, we'll be listening to some podcasts later on in this class from what's called the Post Carbon Institute. They are a think tank, and they're actually funded by donations from people all over the world. All right, we'll give them a couple bucks, but they're not funded by some big old oil company or anything like that. All right, or George Soros or anything like that. They're just people trying to collect money, asking you for a couple bucks every once in a while. But some of them are actually financed through big donors, and they're not really asking for contributions. They're just here's $1 million from the Koch brothers, just go at it. Okay, so check where these institutions are funded. That's very important. Where was the evidence for competing theories published, and has it undergone partial peer review, or is it only proprietary publications? So, like I said, with the ecological footprint, all their data is out there for you guys to check, double check. Just like that guy says in the video that we watched, the most important video ever see at the very end, he goes, "You check my data, check my math." All right. If that person writing the paper or telling you what is not, telling you something, is not willing to release their information and show you how they actually came up with that conclusion, you can almost kind of wash it away and say, hey, this really might not be something. All right. But that's what critical thinking is all about. It's finding out if something is actually really true. And sometimes when someone says, oh, I don't have that information, you could probably say that's a bunch of baloney. All right? So don't be afraid to use your baloney detector and your critical thinking skills in this class. All right? I want you guys to use those immensely, because the next things we're going to be going through for next week, we're going to start talking about some of the basic physics and ecological principles that guide the science that guide our environmental ethics out here. Right. So we're going to be, next week we're going to talk about the carbon cycle and all this other good stuff that are just, basic scientific things in experiments that you can reproduce and find out for yourself if you want to. Okay. And that's what's so wonderful about environmental science. Okay, so this one was a quick one, and like I said, I'm getting used to this, trying to get used to doing this online teaching stuff. So Just bear with me and we will get through this together, folks, okay? So if you have any questions, please don't be afraid to contact me at bachknight.ed at rmu.edu at any time and try to get back to you. Okay? Thanks.